Today's lesson is 2-6, Ratios and Proportions. This study guide is included in this folder, so you're welcome to print it out and write on it, or just follow along in the video if you'd like. So a ratio is basically just a relationship between two numbers. It says a ratio is a comparison of two numbers by division. The ratio of x and y can be expressed as, and then I'll zoom in here, it can be written a few different ways. You can write it with the word 2 in the middle, x 2y. You can write it with a colon in the middle, x dot dot y, or you can write it like a fraction, x over y. Any of those are correct to write a ratio. And it doesn't matter what the relationship is, it's just saying in some way, shape, or form, this number x is somehow related to this number y. So ratios are usually expressed in simplest form, and if they're not in simplest form, you can reduce them, right? You can put them in simplest form. A proportion is when you set two ratios equal to each other. If we have two different fractions, but they are both equal to each other, we can set them equal to each other, and that creates what we call a proportion. To determine whether two ratios form a proportion, express both ratios in simplest form or check for equal cross products. So here's the first example, and I'll zoom in here so we can focus on that. Example 1, determine whether the ratios 24 over 36 and 12 over 18 are equivalent. Write yes or no and justify your answer. Justify your answer just means show your work. That's it. So if we reduce, or if we simplify 24 over 6, I can divide the top and the bottom both by 12. So 24 divided by 12 is 2. 36 divided by 12 is 3. 24 divided by 12 is 2. 36 divided by 12 is 3. So this is equal to 2/3. I can also simplify 12 over 18. I can divide the top and the bottom both by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. So this is also equal to 2/3. So since both of these ratios, or these fractions, are equal to 2/3, then we can just cut out the middleman 2/3 and say that they're equal to each other. So here the ratios 24 over 36 and 12 over 18 form a proportion because they're equal when expressed in simplest form. They're equal when not expressed in simplest form, but we can see that they're equal when we simplify them both. Okay, example number 2. Use the cross products to determine whether 10 over 18 and 25 over 45 make a proportion. So all we are going to do is multiply across, diagonal, right? So we're going to take 18 and multiply it by 25. And we're also going to take 10 and multiply it by 45. And it does not matter which you do first. It doesn't matter. 10 times 45 goes on one side of our equal sign. 18 times 25 goes on the other side of our equal sign. So it doesn't matter which side goes which. So yeah, once you cross multiply, you set it equal to the other cross multiplication. Call them cross products. So now 10 times 45 is 450. 18 times 25 is 450. So since we get the same number on both sides of the equal sign, this does create a proportion. The relationship between these two numbers is the same as the relationship between these two numbers, right? If we multiply these two, it equals the same thing as if we multiply these two. So therefore, this is a proportion. These are equal fractions. If we were to simplify, right, 10 over 18, I can divide the top and the bottom both by 2. I'll write it down here. 10 over 18 divided by 2 divided by 2, that gives me 5 over 9. So that's the ratio in simplest form. And then 25 over 45, I can divide the top and the bottom both by 5. As long as you do the same thing to the top and the bottom of a fraction, you're not changing the value of the fraction, you're just changing the way it looks. So 25 divided by 5 is 5. 45 divided by 5 is 9. So since both fractions are the same, once you simplify them, they are equal to each other. They create a proportion. So that's all we're looking at today. You can either simplify fractions and compare them, or you can cross multiply. Either one works, whatever is easiest to do. So let's look at a few of these. Okay, so we have to determine whether each pair of ratios are equivalent, and we're just going to write yes or no once we show our work. So 1/2, is it equal to 16 over 32? We're asking if they're equal to each other. So we can either set them equal to each other and cross multiply. I guess we don't have to set them equal. We can just cross multiply. Or 1 over 2 is in simplest form. We could put 16 over 32 in simplest form. So if we put that in simplest form, we can divide the top and the bottom by 16. So 16 divided by 16 is 1. 32 divided by 16 is 2. So since 16 over 32 is equal to 1/2, yes, this is a proportion. They are equal. Okay, number 2. We have 5 over 8 and 10 over 15. So we can cross multiply. And once we cross multiply, I can get 5 times 15 is 75, and 8 times 10 is 80. So 5 times 15, 10 times 80, or 10 times 8, that's 75, that's 80. These are not equal. They're not equal ratios. So we would just write no. Right? Also, we could have simplified 10 over 15, divide the top and the bottom both by 5, and we would get 2/3. And 2/3 is not equal to 5/8. Okay? Then we've got 10 over 20 and 25 over 49. So we can simplify. It doesn't look like I can simplify 25 over 49, but I can simplify 10 over 20, which is 1/2. Well, we know 25 is half of 50. So if this number down here was 50, then 1/2 would equal 1/2, right? But since I can't even reduce this fraction, it's in simplest form, but this fraction can reduce down to 1/2, we already know these aren't going to be equal fractions, equal ratios. I'm actually going to multiply visually to show. Okay, so I've got 20, let's get this over, 20 times 25, and if it is a proportion, it should be equal to 10, I think I said over, but I meant times, 10 times 49. 20 times 25, 2 times 25 is 50, so 20 times 25 is 500, 10 times 49 is 490, and while they're close, they are not equal. So these are not equal, we're gonna write no. Okay, we'll do a couple more, flip it over to the back, and then we're done with today's notes. Easy peasy. All right, 25 over 36, 15 over 20. Neither one of these is in simplest form. So first of all, actually, I lied. 25 is a perfect square and 36 is a perfect square, but there's nothing that I can divide the top and the bottom both by. It looks like it started out as a number and I squared both, but I can't just divide the top or the bottom by the same number. 15 over 20, I can. So that's a red flag right there, that I can't simplify one fraction, but I can simplify the other. Then I know that this is not a proportion. I'm also going to cross multiply this one again just to show my math. 25 times 20 equals 36 times 15. They will be equal when I get done if this is a proportion. So again, 25 times 20 is 500. And 36 times 15, well, 30 times 10 is 300. And 6 times 5 is 30, so this will be 330. And these are not equal to each other. So this is a big fat no. Okay, number 5. We have 12 over 32 and 3 over 16. I can divide this, I can simplify this first ratio. I cannot simplify the second ratio. So 12 over 32, if I were going to simplify that, I can divide the top and the bottom both by 4. 12 divided by 4 is 3. 32 divided by 4 is 8. So that's equal to 3 over 8. This other ratio is 3 over 16, and it's in simplest form. So 3 over 16 is not equal to 3 over 8. This is not a proportion. I want to get to another one that is a proportion. Okay, for 4 over 9 and 12 over 27. If I simplify 12 over 27, I can divide the top and the bottom both by 3. 12 divided by 3 is 4. 27 divided by 3 is 9. So I get 4 over 9. And I already have 4 over 9. So we know they're equal to each other. So yes, this is a proportion. We just write yes. All right, so hopefully that gives you guys an idea. You can either simplify fractions and compare, or you can cross multiply and compare what you get. either way, you should have numbers that are equal, and if they are not equal, then it does not create a proportion. Okay, second page of notes. Back up a little bit. 2-6 study guide and intervention, more ratios and proportions. Now we're going to use them. Now we're going to figure out how to solve a proportion. It's very, very easy. We're going to use cross products again. If a proportion involves a variable, you can use cross products to solve the proportion. In the proportion, x over 5 equals 10 over 13. X and 13 are called extremes. They are the first and last terms of the proportion. 5 and 10 are called the means. So if we read this in order, x would be the first thing we say, right? X divided by 5 equals 10 divided by 13. So the first thing we say and the last thing that we say are extremes. This x and this 13 are the first and last things we say. The means are the middle numbers that we say, right? X and then the divided by 5 equals 10 divided by, that part is the middle part. So those are our means. They're the middle terms of the proportion, and in a proportion, the product of the extremes is equal to the product of the means. That's a really, really complex way of just saying cross multiply and set them equal to each other. It's literally that simple. So here, solve x over 5 equals 10 over 13. We are going to cross multiply. Now it already tells us that they are equal. It already says it's equal. We're not questioning if it's equal or not this time. On the other paper we did. Here it tells us that they're equal. So we know this is a proportion. So to solve for the missing variable, we cross multiply and set them equal to each other, right? So we've got x times 13, or 13 times x, equals, because there's an equal sign, 5 times 10. 5 times 10. 13 times x is 13x. 5 times 10 is 50. And to get x alone, now I need to divide both sides by 13. The 13s cancel. 50 divided by 13. They just simplified that fraction. If we have 50 over 13, we can separate this into a few whole numbers, right? So I've got my first whole number. The top should add up to 50. My second whole number, now I've got 26. My third whole number, now I've got 39. My fourth whole number is too much, right? 39 plus 13 is more than what I need. So I can't add any more whole numbers. So 13 plus 13 plus 13 is 39. I need 11 more to get to 50. So 13 over 13 plus 13 over 13 plus 13 over 13 plus 11 over 13 adds up to 50 over 13. And then each fraction that I have, that's just a number over itself, that's one whole. It's not a fraction, it's one whole. If you ate 13 slices of a 13-slice pizza, you ate one whole pizza. Right? So this is saying 1 plus 1 plus 1 plus 11 over 13, which gives us 3 and 11 over 13. Remember what I told you in one of the previous lessons, that you do not want, I hope I said it in this class, it might have been a different class, I don't know. You do not want to include decimals in an answer that did not have decimals in the problem. If you are working with fractions, which we are here, we have two fractions, and your answer is not a whole number, you want to leave it in fraction form. You don't want to use decimals if you've got fractions in your math problem. Leave it all in the same. Okay, so down here, I'll zoom in a little bit. We'll do a few of these. So they are equal to each other. This is, in fact, a proportion. Solve each proportion. So we're going to cross multiply to solve for the variable. So I'm going to multiply x times 2 and set that equal to negative 3 times 8. Remember, it doesn't matter which side goes first. I could have said, negative 3 times 8 first, equals 2 times x. That's fine. Doesn't really matter. As long as you have one on one side of the equal sign, one on the other. So I've got 2x equals negative 24. So that means x is going to equal negative 12. And there I go. That's my answer. I'm going to skip this one because I don't have space to do it. Number 7, I'm going to cross multiply. Now, this doesn't just have one term. It has its adding, but I'm still going to do it the same way. I'm still going to solve it the same way. So I'm going to multiply 9 times 54, set that equal to multiplying the other side. So I'm multiplying 18 times y plus 1. So here, I just have to distribute. I'm still solving it the same way. I just have to get rid of those parentheses to solve. So 9 times 54, 9 times 5 is 45, 9 times 50 is 450, 9 times 4 is 36, so that would be 486 equals 18y plus 18. I'm trying to get y alone, so I need to subtract 18 from both sides of my equal sign. I'm going to skip this because I'm going to run out of space. Okay, so these 18s cancel, and I'm left with 18y here. 486 minus 20 is 466, but it's 2 more than that, so 468. And then divide both sides by 18, and luckily I have a calculator right here. 468 divided by 18, 26. So y equals 26 for that one. Yeah, it was a little bit of work, right? This is the kind of stuff I want to see when you're solving your homework. Please do not write y equals 26, because I know good and darn well you couldn't have done all that in your head that quick, right? I'm a math teacher and I had to write out the steps to solve. Even using my calculator, I still wrote out the steps. I want to see that first you cross multiplied, then you distributed, then you solved for y correctly. I want to see all the work. That's what the points are for. Let's do a couple here and then we're all done. Number 2, 1 over t equals 5 over 3. So I'm going to cross multiply. 5t equals 1 times 3. 5t equals 3. Divide by 5. Divide by 5. So t equals 3 over 5. I'll skip this one because I don't have room. Then we have 3 over d equals 18 over 3. Cross multiply. 3 times 3 is 9. Here, I'll write it. 18d. 9 equals 18d. Divide both sides by 18, not 9, 18. And 9 divided by 18 simplifies to 1/2. So I get d equals 1/2. Don't say 0.5. There's no decimals in the problem, right? Hopefully that's making sense to you guys. Just cross multiply and then solve for the variable. If you have to distribute, then you have to distribute. Do whatever you have to do. And when you write your answer, I didn't have room up here to write t equals in front of the 3/5, so I put equals t on the end of it, but really, that was kind of a no-no. I should have said t equals 3 over 5. That's how you always need to write your answer, with the variable first. Even though they're the same thing, this is not wrong, but it's written incorrectly. You didn't finish it. You got to write the variable first. Okay? Let me know if you guys have any questions on your practice worksheet, and make sure you get that in by Friday. Thanks.